So what we have here is a rational equation, but it's a strange one. So first, I want to show you kind of a shortcut because, yeah, we have a rational expression minus another rational expression, and there is a generic way to solve it. But I think it's worth noticing that these two are exact reciprocals of each other. You flip this, you get that. So if we say, let x be a over a plus 5, then this equation becomes x minus 1 over x equals 0. Or better yet, x equals 1 over x. Yeah, if you take a number and you subtract its reciprocal and you get 0, that means a number is the same as its own reciprocal. And there are just two numbers that do that. If you multiply both sides by x, we get x squared equals 1, which means x is 1 or negative 1. We shouldn't start celebrating because we're halfway through, right? Now we have two possibilities. If x is 1, that means that x, which is a over a plus 5, is 1. So we have a cute little linear equation after we cross multiply. A equals 1 times a plus 5. And then 0 equals 5. So there is no solution from here. And if x is negative 1, then we have x, or a over a plus 5 is negative 1. So a equals minus a minus 5. So 2a is negative 5. So a is negative 5 over 2. You know how to check, but well, let's just do it anyway. So a over a plus 5 is then negative 5 over 2 over negative 5 over 2 plus 5, or 10 over 2. And that's negative 5 over 2 over 5 over 2, or negative 1. So negative 1 minus negative 1 is going to be 0. So this is an important shortcut, and it's good to recognize when you have certain symmetries in the equation. But let's just pretend for now that we didn't notice any of this. Then what we have is, well, we have two fractions with unknowns all over the place. So we can either bring them to the common denominator and then wipe out that common denominator by slick multiplication, or just start with that multiplication. So to clear the denominator here, we would have to multiply by a plus 5. For this one, we would need a. So we're going to multiply both sides of this equation by a times a plus 5. And so when we take this a over a plus 5, and we multiply it by a times a plus 5, a plus 5 cancels out, and we're left with an a multiplier. So what we have here is a squared. And then similarly, a plus 5 over a times a plus 5. Now a cancels out, and a plus 5 is left. And we can, again, FOIL and simplify, but also there is the difference of squares theorem, right? A square minus another square can be factored. Well, I'm going to pretend we didn't notice that. So then we have a squared minus a squared plus 10a plus 25. And so we have a squared minus 10a minus 25 equals to 0. A squared cancels. 10a is negative 25. And so a is negative 25 over 10, which when we get rid of the extra 5 is going to be negative 5 over 2. We got the same answer. That's always encouraging. Thank you for watching.